The moment Elon Musk spoke about expanding production as fast as humanly possible, his hesitation wasn't a sign of uncertainty, it was the quiet before a revolution. Hidden behind those words is a transformation so big that the automotive world still hasn't fully realized what's happening. Right now, Tesla's 2026 Model 2 production line is operating at a pace that pushes beyond every limit the industry once believed was fixed. The line is producing close to 3,000 cars every single day, moving with a level of precision and speed that feels less like manufacturing and more like observing an advanced scientific process. Welds, stampings, and assemblies flow together in a rhythm that makes even the most seasoned engineers stop in disbelief. What lies behind this new line? And can this insane manufacturing ecosystem truly give Tesla the advantage needed to surpass long-established giants? Those questions shape the entire future of the EV landscape. Understanding Tesla's rise starts with taking a close look at the machines and systems powering this new production era. These machines don't just break rules, they rewrite them entirely. For years, the idea that a vehicle could move from raw steel to a fully assembled car in record time felt like a fantasy, something that existed only in ultra-optimistic simulations. But Tesla is proving that this is real. What makes this new line incomparable to anything in Detroit, Munich, or Shanghai? It begins with the foundation of their mechanical ecosystem, the upgraded Gigapress. Tesla's latest Gigapress exerts a massive 6,500 tons of clamping force. That force is strong enough to form large structural pieces in a single movement. For the Model 2, the press creates the entire underbody as one unified piece. Traditional manufacturing requires more than 200 weld spots to create the same structure. Tesla eliminates all of them at once. The result? A 62% reduction in defects and a frame that is 32% stiffer than a comparable frame. Made through old-school body and frame methods, that added stiffness translates directly to improved handling, smoother cornering, and a solid feel on rough terrains, something Model 2 owners will notice immediately. And because the press uses advanced US-sourced aluminum alloys operating at 1,150 degrees Fahrenheit, the material yield reaches an unheard-of 97%. Most automakers reach only around 82%. That difference saves Tesla roughly $750 per vehicle in scrap material. Those savings matter enormously in markets like Texas, where many Model 2 South are expected to be produced and sold. Tesla can pass part of that cost reduction to consumers, pushing EV affordability into territory competitors simply cannot touch. But the Gigapress is only the beginning. Tesla's robotic workforce, made up of roughly 850 ABV robots, forms the next major piece of this manufacturing evolution. ABB, a Swiss-based robotics company, competes in the global top 3 alongside Japan's Fanuc and Germany's Kuka. What makes ABB's robots special at Tesla isn't just their capability, it's their versatility. They come with ultra-fast tool-changing systems that allow a complete tool swap in just 9 seconds. A robot can weld for several minutes, switch tools automatically, then start tightening fasteners or inspecting structures without a human ever stepping in. This ability radically reduces downtime and boosts throughput. These robots can handle 16 different Model 2 variations in a single shift. With that flexibility, Tesla achieves production targets around 1,650 units per day just from these robotic lines, on 18% improvement over what the Model Y line currently achieves. Speed, though, means nothing without precision. Tesla knows that. Each robot uses advanced strain gauges to ensure 99.5% accuracy when installing bolts. Alignment errors fall by 38% thanks to this feature. That matters even more in humid states like Florida, where electrical connections can degrade over time. Tesla's Nevada testing centers confirmed this benefit. Similar precision systems reduced service calls by 22%. This creates a noticeable difference in reliability and long-term performance for customers. Then comes quality control. Legacy automakers still rely on random sampling. Tesla checks everything in real time. Using 3D laser scanners and automated measuring tools, the system evaluates every panel seam, weld, and joint with micron-level accuracy. When something goes wrong, the system instantly sends a correction request to upstream robots. That reduces error correction time by half and pushes first-pass yield rates to an extraordinary 99.7%. Ford and Volkswagen operate around 97 to 98%. It seems small on paper, but in production environments, that gap represents millions in savings and thousands fewer vehicles needing rework. Tesla's advantage grows even more when you examine material flow. Automated guided vehicles and conveyor lines move components at almost 20 feet per second, double the speed of many EV factories worldwide, which average just under 10 feet per second. The faster flow eliminates pause points, ensuring a smooth, uninterrupted sequence from one assembly stage to the next. That smooth flow enables the end result, a staggering output of 3,000 Model 2 units per day. With around 960,000 vehicles per year possible from a single factory, Tesla could dwarf the production goals of competitors who still struggle to scale. Process innovation doesn't end there. Tesla's new battery docking stations use hydraulic clamps that reduce installation time from 12 minutes to about 2.5 minutes. That improvement supports around 350,000 units per year from a single line while maintaining 94% uptime. It's a notable margin above companies like Lucid, whose Nevada operations still struggle with scale. Tesla also integrated in-house thermoplastic molding, which recycles nearly 90% of waste material. Each batch of 7,000 vehicles produced prevents roughly 45 tons of waste. Texas rewards sustainable manufacturing with grants and rebates, and those savings ultimately lower the price for Model 2 buyers. The company is creating a feedback loop where efficiency benefits customers directly. Strategic advantage no legacy automaker has fully leveraged. Walking into a Tesla factory feels like stepping into a futuristic ecosystem where machines, sensors, and humans work in perfect harmony. Robots adjust on the fly. Material flows without interruption. Workers handle advanced tasks instead of repetitive ones. Tesla isn't removing craftsmanship, it's enhancing it. They've turned factories into hyper-optimized environments where technology amplifies human skill. This is Tesla's philosophy. Work smarter, not harder. But at a scale no competitor has matched. The question then becomes, which breakthrough matters the most from a future owner's perspective? For some, the ultra-strong Gigapress structure provides long-term durability, making the model to feel secure and built to last. For others, robotic accuracy and fewer service visits prove Tesla's reliability. And for many, sustainable manufacturing and cost savings show that buying a Model 2 isn't just a smart choice, it's a financially intelligent one. Everyone has a preference. But the bigger picture remains the same. Tesla is reshaping vehicle production from the inside out. Still, machinery tells only half the story. To understand Tesla's true dominance, you must compare the entire system, not just parts, to what companies like Ford, GM, Volkswagen, and Toyota are doing. The industry revolves around three critical metrics: speed, precision, and scale. Most manufacturers excel at one or two. Tesla excels at all three simultaneously. Their integrated system widens the performance gap with every quarter. The numbers make this undeniable. Ford, for example, still takes between 18 and 21 hours to fully assemble an EV depending on the model. Tesla is approaching numbers under 10 hours and pushing toward single-digit assembly times. GM operates factories with roughly 75 to 80% automation in key lines. Tesla, depending on the department, runs between 88 and 95% automation. Volkswagen's ID series lines produce between 900 and 1,100 vehicles per day at peak efficiency. Tesla's new line triples that output. Toyota, known for legendary manufacturing discipline, still relies on dozens of smaller stamping operations that require multiple weld stages. Tesla replaces most of that with single-piece castings. The specs get crazier when you compare energy efficiency. Tesla's Gigapress system consumes significantly less energy per unit produced because it replaces hundreds of welding operations with a single cast that cools rapidly, Battery installation, automated screw fastening, present, and real-time inspection systems also reduce wasted cycles, saving electricity and worker time. When all of these innovations combine, Tesla's cost per vehicle produced continues falling while other automakers face rising labor and material costs. Another major gap emerges in flexibility. Most legacy automakers cannot switch between vehicle variants on the same line without stopping production for hours. Tesla's robotic tool change system adjusts in seconds. When markets shift or specific trims surge in demand, Tesla adapts instantly. Others must halt production, reschedule shifts, and physically reconfigure hardware. That alone gives Tesla a competitive advantage that its competitors can't replicate overnight. All these improvements help create a system that scales with almost no friction. When Tesla wants to double output, it simply duplicates clusters of robotic lines and Gigapress stations. Traditional automakers must expand facilities, hire more workers, retrain teams, and reprogram entire assembly networks. Tesla's factories behave more like modular data centers, adding capacity incrementally with minimal disruption. This scaling advantage